very, very beginning. But here we go. So, guys, welcome to everyone who's joining us today for the Energy and Clean Tech Showcase. I will be your host. My name is Asher Rudensky. Um, these are, we're doing two sessions. There's going to be about eight companies presenting, maybe nine, but Brian could correct me, but I believe it's eight. So, what's the vision? Deep Tech Showcase. Our goal is to bring as much deep tech to market as possible, right? There's a lot of really good ideas out there, like everyone on this call already knows, mostly. That being said, getting the ideas to market is a difficult problem set to work through, and it sounds easier than it might be. So, what we're trying to do is bridge the gaps by connecting startups with tech scouts, whether it be government or corporate, to also investors. So, these startups need all kinds of different levels of help and different stakeholder collaboration for them to really thrive and do what they need to be doing. So this is what we are working on. And anchoring these are our showcase events. We have one a month. Each one has a different topic. This one is energy and clean tech. Next one is going to be industry 4.0, followed by semiconductors. And I'm giving away the slides ahead of time. In addition to that, if you're on this call and you're interested in a startup, our goal is to connect people, right? We don't just want to have these showcases. You see a bunch of companies say, that was cool. I'm never going to think about this again. No, our goal is to have the companies actually work with the folks on the call. So if you see something that you like, let us know. Feel free. And this is the slide I already gave away. These are our next two showcases, Industry 4.0 on April 29th and Microelectronics and Semiconductors on May 20th. All right. So we're gonna have let me see if Yoav or Joe is on the line to tell us a little bit about our parent company, Eagle Point Funding. Otherwise, I can quickly just tell everyone on the call, because I know that Brian probably wants us to take the time. But essentially, Eagle Point Funding is a grant writing consultancy. They sponsor a lot of these events. And what the goal with them to connect the startups that we see a lot of the times with non-dilutive funding, whether it be SBIRs, STTRs, BAAs, OTAs, et cetera, et cetera. Brian, I believe, will leave a link in the chat for folks that are looking for grant writing or need help with grant writing. That's definitely something that we can help go over and talk about. In addition to that, we're always happy to. In addition to that, I mean, just to give some updates on the federal sides of things, SBIR was mostly reauthorized. We're just waiting for President Trump to sign to for them to present. I know that some of the people just nodded on the call. I know that there's a lot more than just me following this, but President Trump is supposed to hopefully sign the legislation into action, and then we could get going again. One interesting thing, and I don't know if any of the DoD folks on the call want to field this question, but how it's going to work with dispersing the funds that have accumulated over the course of the past, it's been since October. So it's been like 5, 6 months since the funds have been dispersed. So we will see how that happens, and feel free to book a call with Eagle Point Funding if you want to talk more about that or try to figure out what's going to happen. In the interim, what I'm going to do is I'm going to go around the panel and have folks introduce themselves, tell us a little bit about yourself. We actually do have time for this session, so feel free to tell us a little bit more about what you're interested in the energy and clean tech space, and give us a little overview. So first up will be Mark. You want to go first, Mark Vreek?
Happy to. Uh, my name is Mark Reka. I run the Chemical Angel Network, and we're an angel network like any other. We invest our own money in early stage, seed stage companies. What sets us apart is the chemistry focus. We cast a really wide chemistry net. In the clean tech space, a lot of this is driven by the materials uh, and the processes for greening or cleaning a product production line or a chemical production line. And so that's where we sit.
Awesome, pleasure to have you.
Thank you.
Next, absolutely. Next up, we have Greg Bauer.
Hi, everybody. My name's Greg Bauer. I'm the managing partner of Scale Up Labs located in Cambridge, Mass. We're a venture firm, excuse me, and startup builder. We invest in three sectors, all AI native startups and health tech, advanced manufacturing, or energy sustainability, hence the call here. And average ticket size for us is we're seed and stage A, so average ticket size for us is 500K to 5 million.
It's a pleasure to have you.
Thank you. It's good to be here.
Absolutely. Next up, we have Cooper Bates.
Hello, everyone. Happy to be here. I'm with Clean Energy Ventures. We're an early stage venture capital fund focused on climate technology that has the potential to mitigate carbon emissions by multiple gigatons over the next three decades or 30 years. We typically invest, $1 to $10 million in the funds that we invest or in the companies we invest in, and we're focused across the entire climate tech landscape, basically anything that's decarbonizing a heavy emitting vertical. Last thing is that we focus on companies in North America, but now Europe and Israel as well.
Thank you. Thank you for being here. Next up, we have Joseph Weiler.
Hey everyone, great to meet you all today. My name is Joe Weiler. I'm the Managing Director of Investments at HL and City Rock Ventures. We're a family of funds and a studio accelerator focused on backing companies that have a positive impact on people and planet, defined very broadly. Obviously, within that, we spend a lot of time on climate sustainability, decarbonization. My personal background is also in that space. We invest everything from pre-seed through Series B. Typical initial check size is 500K to 2 million.
Pleasure to have you. Next up, we have Marissa McGinnis.
Hi, I'm Marisa Alma McGinnis, and I'm located in Silicon Valley, Burlingame, which is between San Francisco and Palo Alto. So my focus is healthcare and longevity and AI and defense. And I'm an LP with R42, and then I do a lot of private investments in real estate, gold, etc. Thank you. Nice to be here.
It's a pleasure to have you. Next up, we have Han Ko. Han? He was here a second ago.
Yeah, I'm here. I'm sorry. I was
Okay.
my mute button was unmute button was hidden. Sorry. Hi, Hanko here. How you doing, everyone? Always pleasure to be part of this great program. This program has been really benefit to us and our portfolio companies, and thanks so much for that. Cycle Group is my company, and it's what's unique about us is that we have a presence around the world. I have office from West Coast to Midwest and East Coast and all the way to South Korea. So our portfolio includes a lot of companies from overseas, as from Europe to Asia. So so we have a pretty large footprint globally, and our focus is on the clean tech and energy. It's our favorite topic, actually. We're geared toward this topic this year, so it's perfect topic. And also, our check size is from half mil to about 5. So we are looking forward to working with you, and those who are presenting today, good luck. Thank you.
Absolutely. Pleasure to have you. All right, Bill Weber, you want to go next?
Sure. Bill Weber, in 3M Ventures. We invest in companies of strategic relevance to 3M. Series A, I would say, is our sweet spot. We can go earlier, we can go later. $1 to $5 million check sizes. Our interests are broad, but among them is energy and climate tech in general, and also aerospace this year.
Sure. Thank you. Thank you, Bill. Paul Garcia, you want to go next?
Sure. Thanks again for inviting us, Asher. Paul Garcia with the Air Force Office of Energy Assurance. I am support staff from Booz Allen. Our office works on utility scale energy, that's power and water, so fixed utilities and the infrastructure that goes with that for all 200 Air Force bases around the world. the current things that we're working on in energy, since this is my favorite topic here that you do. We are working in geothermal energy. We are doing hydrogen, particularly geohydrogen. We have activities going on in multi-fuel generation. And coming up very soon, we have a solicitation for advanced energy storage. That is anything non-lithium, absolutely anything non-lithium. And we are standing up a consortium that will be able to accept new members, we expect next year. The difference with the consortium that you may know today is most of them are just research. Ours includes a couple $2 billion of funding, so we have our own money. And speaking of our own money, there is a very high probability that we will have a lot of money to buy ready products in the rest of this year. So, Asher, that's news to you. I just heard today that we're gonna get lucky.
Oh, that's good. That's good to know. Okay. We should talk offline.
Normally we rely on third-party financing for everything, but I don't think we'll need to anymore.
Wow. Okay. That's awesome. That's good to hear. Perfect.
On to
All
next.
right. Exactly. So pleasure to have you. Next up we have Avery Liu.
Hi, Avery Liu, based in the Bay Area, South Bay, Silicon Valley. Two organizations I belong to. One is the Venture Capital Roundtable, is an angel group. So we look at seed and then Series A up to $1.5 million. So we look at a lot of things, including energy. And then on the VC side, a venturing capital group, we look at foundational patents in different areas, 6 practice areas, of which energy is also one of them. Of course, AI, quantum computing, life science, and new materials and platforms and systems. So it can cross-pollinate.
It's a pleasure to have you. All right, Brad Casta, you want to go next?
Yep. Thank you, Asher. Yeah, so I'm Brad Castro. I work for Cook Inlet Region, Inc., also known as CIRI. It's an Alaska Native corporation where we operate in 2 specific verticals. One is we do buy and build strategies in environmental services, aerospace and defense manufacturing, and cyber and IT services. And then our venture portfolio, we like to tend to align to those subsidiaries and then also align to energy as well. So we consider ourselves deep tech seed investors for that scenario. We'll invest anything from $250K to $1 million, roughly can go higher or lower based on the company size that we're looking at. And then through our status and our subsidiaries, we like to align our investments to be able to deploy on contract through them. So looking forward to hearing more about the companies today.
Absolutely. It's a pleasure to have you. And then I think last, unless I'm missing someone, but Peter, you wanna say hello?
Yeah, I think I'm the only government, well, I'm still the Air Force, but Peter Reese with the Kansas Department of Commerce. And although I'm Kansas, I live in the West Coast in Los Angeles and work with different types of projects, whether it's aerospace or utilities or whatnot. I can connect you if you're looking for investment, connect you to our Office of Innovation, otherwise connect you to some of the private sector players that are investing in disruptive technologies. I handle all the incentives myself. So if it's a several $100 million project, I'd incentivize it with any state and potentially local incentives, but kind of feel free to use me as a resource or anything.
Sure, absolutely. It's a pleasure to have you. And I misspoke, Kathleen. I think I skipped over you somehow. I'm so sorry.
No worries, no worries. Hey, folks, happy to be here. I'm Kathleen German. I'm with Dow Ventures. Dow is a strategic investor, primarily in materials and chemistry. A is our sweet spot, but we can go earlier or later, $500,000 to $5 million check size. We're interested in circularity, alternate routes, bio-based routes for conventional petrochem-based routes to materials, Industry 4.0, and anything supporting basically chemical manufacturing. So looking forward to seeing the startups.
Sure, it's a pleasure to have you. And then I think, oh wait, there's a few more people have joined while we've been talking. So Mark Morgan, you want to go next?
Yes. So Mark Morgan, I'm with the Air Force Civil Engineer Center. We basically support AFWERX and SBIR, STTR process. I'm glad to be on here listening to the company's pitches.
Absolutely. It's a pleasure to have you. And Utkarsh, you want to say hello to everyone?
Hey everyone, hey Asher, Utkarsh from Vertiv, Technology Innovation Manager. We look forward to technologies within advanced data centers and its related companies.
Sure. Awesome. If I did not get to someone, feel free to speak now, but uh, perfect. And there's a few people who are supposed to be in session 2 that are here early, so welcome. If you want to be engaged, feel free to be engaged. If not, that's also okay. Now we will get to the main part of the event, the presentations, and we're going to start off with Evident Battery. And I believe the screen should be shareable whenever you're ready to go.
All right, cool. Thanks, Asher. I'll share my screen. All right, just want to confirm, can everyone see my screen now? Okay, great. Hi, everyone. My name is Jin Qiangning. I'm the CEO and founder of Evident Battery. We offer vibration-based inspection and monitoring for mechanical failures. So our verticals across machine house and transportation safety. We use fundamental AI algorithms to detect a lot of mechanical issues in a non-destructive manner. So sudden mechanical failure impose significant losses across machine house and transportation. Machine house equipment house side, based on Siemens data and planned downtime, cost $1.4 trillion for the Fortune 500. That's about 11% of their revenue in 2024. Transportation-wise, according to the U.S. National Security Safety Council, motor vehicle crashes cost like over $500 billion in 2023. A lot of mechanical degradations cause those issues, and after accident, lots of damage to the mechanical side as well. Overview about Evident Battery. We're a company VC backed. We raised this $3.2 million seed round back to later 2024. We are based outside Boston. Our focus is on manufacturing and AI. We have a lot of expertise in manufacturing, sensor hardware, and AI analytics. We offer 2 major solutions. One is vibration-based monitoring. We develop a unique sensor that runs on Wi-Fi. It can detect mechanical issues for industry machines and also mobility applications. The second solution we offer is vibration-based inspection. So that one will not only use the vibration sensor to read responses from the structural components, we also excite the structural components using shaker devices. Based on deep learning algorithm, we correlate different failures to different vibration signal signature. That's how we be able to identify mechanical issues without destructively tear down the components or system. The first offering is a vibration sensor using advanced data analysis. So the sensor size is really compact, really small. That's how it looks like. USB-C charging also has its battery. For this one, it's high performance, up to 6.6 kilohertz sampling frequency. So we can look into frequency into my data and log a lot of insights about the machine mechanical health. It's very easy for integration. We use an API-based system for the entire infrastructure. It can be integrated into existing monitor platform easily. For diagnostic, we use AI-based algorithms to detect and process the data. It can be easily scale up from a single asset to over 1,000 assets. And it's a beautiful real-world application, including machine house, transportation, and also research development. So we not only build this sensor for affordable cost, we have unique go-to-market strategies, selling those sensors through self-serving channels. Usually the deal close time is just a few days from initial contact. So traditional players takes like months to go over the site walk, to go over the demo and the contracting process. We don't require that at all. The second offering product is a monitor sensor. It's mainly designed for preventive maintenance. It's completely made in US. It's a couple $100. We can sell a single unit. The sensor itself uses Bluetooth technology, lasts for a year. We have a small gateway that uses Wi-Fi, means a user can get a real-time notification if anything goes wrong. So it can detect a very minor shift in vibration patterns. Based on our test, we can detect a frequency change as small as 2 hertz. So it will trigger based on the event. Every time an event happens, we collect the full spectrogram. We have the buffer system. That means when the event triggers, it traces back to 100 milliseconds before the event happens. We get a full spectrogram instead of a small portion after the event happens. Software side, we offer AI-powered insight at skills. 2 software offering. One is Windows OS installation. It's Device Hub software that can control up to 1,000 sensors. It's a free software we offer to our users. So for the sensor deployment, it can easily scale, as I said, from single unit to over 1,000 units. The second offering, we offer the web-based portal, which is the portal that store the data on the cloud, analyze the data, reveal the insights using the AI algorithm. This is the vibration inspection solution. It's originally designed for EV. Now we deploy this for different structural components, including, as I said, the shaker and the sensor. So the sensor will be used adhesive mounted onto the structural components. We use this shaker to excite the structural components at a certain frequency. By reading the responses compared to the database in the library, we'll be able to identify different mechanical failures, including loosening fasteners, crack or welding, structural mechanical failure like deformation, tear wear, excessive tear wear as well. So here's an example for EV battery pack structural component assessment. Everything can be done in 2 minutes, including deploy the equipment, collect data for 20 seconds, and then use the AI algorithm to analyze the data on the cloud portal. We generate a report telling customer what's wrong mechanically with the EV battery pack, and also where is the wrong. So this technology has been applied to our other structural component analysis field as well. So in the past 3 months, we really start commercial tractions. Those are the customers who bought and use our sensors. We have over 200 units deployed in the field in 4 verticals, including the mobility sector, manufacturing, research development, and robotics. So the sensor can do passive inspection, means you just take the sensor to do inspection at any time engineer or people want to do. You can also do active inspection, means you leave the sensor on devices. It will monitor, track the small vibration shift and the pattern change, and give customer the real-time notification. So the ask here, we're raising a $2 million seed extension round, mainly to grow those small sales, pilot sales with those customers to executive accounts. So we need to expand our sales team at the moment. We're also looking for introduction to prospective customers who need advanced vibration analysis in machine house, transportation, safety sector. So that's all I want to talk about. We will stop here, open to questions. Thanks, everyone.
Sure, absolutely. Thank you for the presentation. And just to remind everyone, you can blurt out your question if you want. Otherwise, ideally, under reactions in Zoom, there's a way to raise your hand. So yeah, feel free to do exactly like Han just did. Han, you want to go first?
Yes. Hey, Jin Quing, right? Did I pronounce correctly?
Yeah, Jin Chang.
I'm sorry. Yeah, thank you. Hey, good presentation and very interesting solution. I know the industry a little bit. And I just want to know a little bit about your take on your competition. I know there's a company doing like X-ray imaging, like I think their name is a Glimpse or something, right?
Yeah.
So they have a high resolution X-ray to look at the battery cells and stuff like that, and how you compare your product to them.
Yeah, I know Glimpse very well. They are under same portfolio. Our lead investor investing in their company as well. So the main difference is for X-ray, you merely scan battery cells, the small component. You can't really fit the entire battery pack or large structural components into X-ray machine. So for X-ray, you prefer to move the part instead of move the machine. For our devices, it's really portable. It can be deployed anywhere underneath the car or structural components. It's also, we don't need to scan multiple passes. It's based on the point input, which is you introduce the vibration at a specific location. The vibration will propagate through the entire structure. So we read the responses. That means a single point input with multiple point reading. In 20 seconds, we can get all the mechanical structural information. So it's non-destructive, it's non-intrusive, and it's easy deployment at much, much lower cost.
Okay. So there's another quick question. So your price point, how's it work?
Yeah, so for this inspection toolkit, we charge $2,000. For every inspection, we charge $40 per inspection. Compared to $500,000 CT scan machine or X-ray machine, it's much, much more affordable.
Great. Thank you. Appreciate it.
Mark, you're up.
Yeah, quick question on your raise. $2 million on what terms, and do you have a lead?
We don't have a lead for this round, and we will just follow the seed round lead. So we call it extension. So it will be 10.2 million post-money valuation.
Thanks.
Thanks.
All right, Marissa.
What is your business model? So the subscription, and then the other question is, you're hardware agnostic.
Yeah, for business model, we charge hardware one-time cost and we charge software subscription. What we offer really is just the AI insight, use the deep learning model, analyze the data, so customer can get a useful information instead of getting the raw data. For hardware, we have a very unique technology here. For this inspection solution, we built everything from scratch, including PCB design, final assembly, testing, qualification, everything ourselves. So that's the reason why it can be affordable. And also we use the self-serving channels to sell those devices. So we don't use traditional sales in person, like meetings, demos, contracting process. We can sell as small as 1 unit in a couple of days. So that's a unique advantage for this technology and the go-to-market strategy.
Okay, thank you.
Thank you.
Well, Greg.
Thank you. Interesting presentation. Thank you very much for that. A couple questions. You said you're located in the Boston area and you have your venture backed. Who's your current venture investors and what were the terms of that raise? That's question one.
Yeah, for the seed round, it was led by IBEX investors, IBEX in Bay Area. We're also supported by Nationwide Venture, the insurance company, and Automotive Venture in Atlanta. So the terms, as I said, is 10.2 million post-money valuation for the seed round. So we decided to reopen this to bring in more money. The purpose for that is we want to build a stronger sales team so we can grow the pilot customers or the customer who bought a few units to be executive customers because they definitely have a much higher demand than just buy a few units.
Okay, perfect. Second question is, when were you founded? What's your current ARR? And who do you consider to be your target sectors?
Yeah, so the company was founded back to the time I was at Yale University pursuing an MBA degree, end of the year 2023. So we've been in the field about 2 years. For the revenue target, right now we're selling devices about $10,000 to $15,000 per month. So we see a significant growth trend in the past 3 months. We're targeting $1 million revenue this year. So what's the last question? The last part.
And what sectors do you focus on?
Oh, the customer. Yeah, so we focus on more broad sector. Originally, we designed this technology specifically for EVs. Now we expand this to machine health and transportation safety. So we're looking for mechanical failure in EV battery pack. So mechanical failure could also happen on a fixed asset, like a stationary equipment there. So it's actually easier for us. And from past experience, we saw that sells faster, quicker, and also bigger market opportunity for us. That's why we expanded.
Great. Thank you.
Thank you.
And Jincheng, I think that's all the time we have for right now.
Yeah.
So leave your email in the chat. I think it looks like there's more conversation to be had. But thank you for that presentation.
Yeah, thanks everyone. Thanks, Asher.
Yeah. Next up, we have Eva Green Tech or EVA Green Tech. Sorry if I'm not pronouncing it correctly.
Yes, Eva, it's fine. 1 second, I'll share the presentation. Okay. Can you see this?
Yeah, we can see it. It's not on presenter mode yet.
1 second.
While you're getting it onto presenter mode, I just want to welcome Winnie Luing from Ajinomoto has just joined. But it looks like you're gonna have to swap the displays because we're seeing the presenter.
1 second. Better?
Yep,
Okay.
there it is.
Okay, I have multiple screens here, so.
All
Okay.
good.
So, hi, I'm Tamara. I'm founder and CEO of Eva. My background is environmental and energy engineering, and in between my degrees, I've led multi-million-dollar engineering projects. In Eva, we are transforming construction and demolition waste into high-performance, low-carbon cement alternative, closing a major supply-demand in a $40 billion market. So the construction is one of the largest industries in the world, and according to the World Bank, we are in the midst of the biggest wave of building growth in human history. So already today, the cement global market is estimated as almost $400 billion. And out of it, there is a supplementary cementitious materials market, SCMs, which are basically the alternatives for cement, which are expected to grow to $40 billion by 2030. But this is not the end of the story. In reality, the SCM market could be much larger, but it is constrained because it's constrained by the limited availability of raw materials. On the left side, we can see that there was a between 30 to 50% increase in cement market prices since 2021 due to resource depletion and green building regulation. This is because cement production is highly polluting. Each ton of cement produced emits to the atmosphere almost the same amount of CO2. And it's also demands a lot of energy. So the result is that the demand for the alternative cementitious materials is rapidly growing. But the traditional materials the industry relies are limited in supply, especially for the ready-mix concrete producers. As legacy SCM's sources disappear, the industry urgently needs a scalable alternative. At the same time, on the right side of this slide, you can see that there are 3 gigatons of construction and demolition waste generated globally each year. We saw here a huge opportunity. Today, old concrete is sent to recycling plants and mostly downcycled into road-based and other low-value uses. EVA changes this. Our solution transforms waste into high-performance cementitious material. We have developed a patent-pending activation process that physically and chemically reactivates construction waste so it behaves like cement again. The material can replace cement at high percentages in concrete production in 1-to-1 ratio. The economics are very strong. For the recyclers, it multiplies up to 5 times the value of the profit on the same material they already receive in their plants. And for the concrete producers, it significantly improves margins through cement replacement, as the cement is the highest expense for the concrete producers. This is why adoption is straightforward. Not only that, the energy that is required for our solution, because it's mostly chemical activation, is only 8% of the energy that is required for cement production. And carbon footprint of our solution is 3% of the carbon footprint for the cement production. In addition to more than 700 mixes that we did in our laboratories, we went for a very broad industry validation, and we completed multiple successful validation tests with many companies, both concrete and cement, locally and globally. One of such companies is Holcim Cement. Our team combines deep research and industrial experience together with strong execution and engineering and scale-up. So in summary, we are addressing a high demand opportunity in a supply constrained market, broad industry validation. We are backed by prominent investors and receive governmental grants, a world-class team of engineers, and a growing IP portfolio. And we are building a commercial pipeline of over $2 million in ARR. EVA is on a mission to turn the world's largest waste stream into the world's most needed building material. We are currently raising our seed round of $4 million. and we invite you to join us in our mission.
Awesome.
Yeah, can
Thank
I
you,
lead
Tamara.
off with a quick question? How pure do your material inputs have to be? You know, when you're tearing down a building, you've got rebar in there, there's all kinds of other stuff mixed in with it. How does that work within your process?
So our input material is mostly concrete waste, which is about 60% of the total construction and demolition waste. And we already know that the demolition waste recyclers are able to provide this kind of material. So we have this as our input in our process. Basically, they have this as their input process, and we provide them an activation mix that reactivates this material. It is very the range is quite broad. Of basically, we are dealing with unreactive material, and we are providing the reactivation.
Thank you.
Sure, Han, you want to go now?
Yes. Yeah, good presentation and also good, very interesting solution there. I also happen to know this industry a little bit because I was doing a lot of research in the past. What kind of patent, what kind of intellectual property you have? I got two questions. Your intellectual property also, don't you have there's a company called like EcoForce. Your company is from Israel, right?
Yes.
I think you have local competition. So maybe you can compare that a little bit. That'd be helpful, please. Thank you.
Okay. So that's a great question. We have a couple of patent pending in process already on the physical aspects of the activation, and currently we have a trade secret on our activation mix of the chemical side of the activation, and another patent is in process as well. Our main differentiation is that we are able to produce high-performance cementitious material that can be applied in every kind of concrete, both non-structural and structural concretes, every kind of concrete. Most of the solutions out there are able to be applied in non-structural concretes, which are only 20% of the market.
Okay, understand. And yeah, well, maybe perhaps we can talk about this offline. Thank you.
Yeah. Okay. Perfect. Thank you, Han. Because there's a few other questions. I appreciate that. All right, Cooper, you want to go?
Yep, thank you so much. Just to extend off Bill's question, how many tons of input do you need from recyclers to produce 1 ton of SCM output? And do you have to pay recyclers for that input? Or are they more than happy to give it to you if you can pick it up for them?
Okay, that's a great question. Basically, the recyclers already received their material. Once the buildings are demolished, they have to bring it to specified recycling plants. So they even get paid by receiving the material. The problem is that today they're processing it, and the most they can do out of it, the value they can take out of this is very low because they sell it as base material. About 40% of their input can be used as input for our process. This process is located in their plant, and we are providing the activation mix to reactivate the base material.
Gotcha. And it sounds like you are paying them then for that.
No, we are not paying them. They're paying us for the activation mix because they are able to, with the economics that basically we're increasing value for the same material. They are getting up to five times profit on the same material that they would get otherwise. It depends, of course, of the scale of their operation, but it's up to 5 on profits on the same material. So they are more than happy to apply this solution.
Well, Greg, and then if it's quick enough, we'll get to Joseph's question. All right, Greg, go ahead. You're muted. Greg, I think you're muted.
Okay, I said I was going to be quick. Maybe I use some time. Really interesting circular economy application. How do you make money? What's your business model?
Our business model is basically we are giving the technology for the process for the recyclers, and we are selling them the activation mix. So the activation mix, we are selling them. The activation mix is produced by the subcontractor, so we don't need to invest in capex. But we do have quite substantial costs, of course, and this is our main business. We are teaching them to set up the process, and we are selling them the activation mix that they need in proportion to their sales.
I would recommend that you look at a company called Harsco. Harsco is headquartered in Harrisburg, Pennsylvania. They're a steel mill services company, but what they do is have a very similar model. As they provide the capital, they provide the equipment on site, and then you acquire the raw materials from the steel mills and resell it. So it would be a really interesting model, and there may be a synergy between what they're doing and what you're aiming to do. Very similar materials.
Sounds very interesting.
Joseph, you want to ask a quick question?
Greg covered it. All good.
Okay, perfect. Awesome. Happy to hear. Awesome. Thank you, Tamara. Feel free to leave your contact information in the chat. And yeah. Next up, we have Orbis Electric.
Thank you.
And I believe that Marcus will present.
Yes. Hello, everyone. Marcus Hayes,
Howdy.
founder. Sorry. Buttons. Come on, buttons. There we go. Hi.
There you are.
Marcus Hayes, founder, CEO of Orbis Electric, based in San Francisco, California. Thanks, Asher and Eagle Funding, for the invitation today. Let's see if this shares.
We're seeing the one with the border. I don't know if you want to try to share the other screen.
Are we seeing the slides move?
Yeah, I saw them move. They
Okay,
moved.
good.
Okay.
Good. All right. I am just not that familiar with Zoom, sorry. I've become so familiar with Teams. Still border?
Yeah, I still see the border, but we can just get started.
Okay,
It's
thank
fine.
you very much. All right. Well, Orbis Electric, we were founded back in 2015. We've been producing novel axial flux modular power systems for going on 10 years. We bring significant advantages in material sciences. According to some of our customers, including Volkswagen and a defense contractor, a prime in the United States, our motor offers the most power and torque density of any motor in the world. We have extensive experience working with Ames Laboratories and other DOE labs developing and co-developing alternative magnetic materials to produce a high volume, highly competitive cost basis for this system. Focus now is in data center cooling. I think we all know what data centers are doing, their growth, their impact. The measurement of efficiency and inefficiency is based on power utilization effectiveness. As any of you who are following data center growth are seeing, Jensen Huang recently discussed DC as being the switch from essentially an alternating current-based operating environment. Well, in DC, that's what Orbis Electric does phenomenally well. And so we've developed a way of improving this formula substantially using our modular power system to take this power utilization effectiveness, or in some cases inefficient systems, into a new realm of of processing efficiency. So very quickly, we will be deploying a cooling distribution unit that is DC native, coupling into an AC environment, but using the efficiencies of DC. And the numbers are staggeringly huge in terms of what seemingly small percentages of efficiency and how those improve. And just as an example, in 1 gigawatt of deployment, a difference in 0.3 PUE is worth anywhere from 4 billion to 2 billion annually in improved utilization of that energy. So getting the energy out of the data center load side where it's not being very productive, all it's doing is facilitating cool water glycol into a high intensity rack filled with GPUs. That utilization is currently captive, and that's what Orbis is doing very well. So we have roughly 16 issued patents, 32 pending on the modular power system. And the deployments that we've done in the VW car, in the defense subsea systems, it's literally the exact same architecture now that's in our so-called cooling engine. And the cooling engine being DC native can plug into solid oxide fuel cells. It can go into gensets. Whatever the customer or the data center operator has, whether it's behind the meter for a Crusoe style deployment or a NeoCloud like FluidStack, we're going to deliver substantial improvements in utilization of their GPUs. Our business includes not just when we call the modular power system, it's not just the axial flux, but we have a telematics layer above that doesn't interfere with anybody else's telematics, but it shows the customer how much more money that their GPUs on the utilization side will benefit from. I mentioned deployments in VW cars. Our systems are on heavy trucks, recapturing kinetic energy, feeding that into electric refrigeration. And so it's the same system being deployed in all these platforms, whether it's cooling engines inside data centers or heavy trucking for electric refrigeration or automobiles, and as I mentioned, a subsea system. We're forecasting about 15 million in rev next year. We are seeking an 18 million currently seeking a lead for that. And we do have a bridge note with very good terms as we work to build into this momentum in the A and build our mass production technology. Thank you very much.
Absolutely. Thank you. Thank you, Marcus. Opening up the floor for questions. While folks are getting warmed up, do you want to? Okay, Han, you want to go first? Go for it.
Yeah, actually, so you guys are expert in motors, huh? I'm really interested in learning more about this, your data center cooling solution, right? So you use your motor, which has a high efficiency to basically move the liquid to cooling the server rack. Is that what you're doing?
Yes, exactly. So our technology, very compact, very light, and with much improved fidelity. So imagine the difference between a light switch or a dimmer switch. That's what our motor does in a data center environment. So when we're pumping fluid in the conventional cooling systems, you have a fire hose that's just dumping massive amounts of volume of glycol water into the adjacent rack. What our system does is control that flow in a way that we can minimize the transient events happening in the rack where the GPUs are exposed to premature failure. So yes, that's what our technology does. It moves the fluid much, much more efficiently and with finer control to improve the cycle life of the silicon.
How's it compare, the price scheme to other competition?
Well, so there are lots of different types of motors, PCB, printed circuit board motors, notably. They're cheaper than we are by about 10%, but they can't match our efficiency or our cooling or our power. So while we do have slightly higher cost, we win back that on efficiency and control effectiveness.
Great. Thank you.
Thank you.
Sure. And so I'll ask, can you talk about some of the defense or other applications this technology has?
Sure. So the same sorts of problems exist in data center cooling that exist in subsea, where we're working with the defense large prime. So the same technology, propelling a vehicle undersea, managing cooling, managing power effectiveness, essentially the same way. So I can't disclose who the prime is, but in a couple of months, I think we'll have a press release about it. But ultimately, the same value propositions there: high torque, lightweight, high power, and then material utilization that, thanks to Ames and collaborations at Oak Ridge National Labs, is an opportunity to really move the world out of neodymium and out of copper and other kinds of material sciences that are sort of putting a drag on these kinds of motors in terms of their market viability.
Greg, go for it.
Thank you. Great presentation. Quick question. What do you plan for the use of funds for the capital you're raising, and where do you see your ARR in 3 to 5 years? 3 years and 5 years, let's put it that way.
Well, ARR next year, roughly 15 million, growing from 800,000 or more this year. I think we'll start to see some unlocks. We've had sort of an extended period of pilots with the primes and Volkswagen refrigerated trucking, but those now have momentum. I think with the deployments into data centers, what's fabulous about the solution in data centers, the value proposition is at least 10x over what we've seen in automotive and other verticals. So we're really excited about the problem solution set. So in terms of margins, we'll see margins in plus minus 60%, 65% gross. In terms of utilization of the capital, so we have contract manufacturers that we're working with. We're not building factories. We're not making the equipment in-house. So we are working already with CDU makers who will deploy our technology that's being produced by other contract manufacturers. So we're very capital lean on balance to what a typical manufacturer might be, with really, really good solid margins, and the amount of utilization in terms of the value we add is something that we can monetize with SURF. So we're not just a motor company. We have this Silicon Utilization Recovery Framework, which is telematics platform. So we start with the hardware, and then our revenue lines start to increase through our software stack. If that makes sense. So I do think we're going to see pretty rapid growth over the next 3 to 5 years.
Okay. What I don't understand is, what are you using the funds for? If you're a contract manufacturer, are they for R&D, for go-to-market, for what?
Sorry. Yes,
what are
go to
these-
market. Yeah,
Go to
go to
market.
market, and then underwriting some of the contract manufacturing processes.
Okay. Thank you.
Thank you.
All right, Winnie, you're up.
Thank you, Marcus. I just wanted to understand the incentive alignment and sort of the investment of the CapEx. Ultimately, who's the party that's going to most likely drive the investment in this, and how is the savings going to be distributed? Do you have a sense in the AI machine learning space or something like this?
Yeah, I think so the delta between the power utilization effectiveness is something that is observed, managed, and relayed in real time. So we see exactly what the difference is between what was and what is, and that utilization improvement is something we can eventually predict. So working alongside an NVIDIA, for example, or other CDU makers, we can monitor the transient events, so-called, where the flow rates have to respond so quickly, if that makes sense. So the ebb and flow of the demand on the GPUs is so rapid that the flow rates don't currently respond fast enough. And so that exposes the GPU to a premature cycle life. So our tech improves that, and we can manage that predictively and monetize it, if that answers your question. So it will take some time for the customers to see that telematics window proven. But in pretty short order, that's where we start to augment our revenue from the hardware side. Does that answer your question?
Thank you, Marcus.
Thank you.
Perfect. I think that's all the time we have, but thank you for the presentation.
Okay. Thank you all.
Yeah, feel free to leave your contact information in the chat.
Thank you.
Next up, we have VGlass. Mike, it's good to see or hear from you. I don't see you yet, but it's good to have you.
Is the deck? Thank you, Asher. Thanks for inviting me. Everybody see the deck at this point?
I see it.
Great. Thanks. Hello, everyone. I am Mike Pettit. I'm a co-founder and CEO of VGlass. We've developed next-generation vacuum insulated glass technology for affordable, ultra-high efficiency windows. See if I can get this to move. There we go. We are targeted at a very large, growing global market. Annual sales for insulated glass is estimated at about $67 billion globally. The problem that we solve is that buildings consume a huge amount of energy, and windows are the hole in the dike where most of that energy is wasted. The Department of War, for example, spends about $3.5 billion annually to power, heat, and cool their 300,000 buildings. Our solution, an affordable window that's as warm as a wall, as illustrated in this infrared image of two VGlass units in yellow that have more than 3 times the thermal efficiency of the dual pane windows you see in blue. This image was taken on a January day in Wisconsin when the outside temperature was -4 degrees Fahrenheit, so you can physically see with this infrared image our superior thermal performance. To show how VGlass fits into the competitive landscape, I've plotted competing window technologies with increasing thermal efficiency, moving left to right, and increasing costs top to bottom. Clear glass and dual pane are low cost, low efficiency. With triple panes, you get a little more efficiency for a little more cost. With first generation vacuum glass, you get more efficiency at a lot more cost. VGlass breaks this cost performance paradigm by having the highest thermal efficiency of any product on the market produced at cost comparable to today's conventional windows. VGlass is also 100% recyclable and has the lowest embodied carbon footprint of any product on the market. Our economic impact will be significant. Output from a DOE climate tool shows that full implementation of VGlass could eliminate 90% of energy wasted by current window stock, which would translate into about 1.8 quads of energy saved and about $30 billion annually in the US alone. The Department of War could save $1 billion annually. Here you see our scale up and commercialization plan. We're currently producing a vacuum glass unit in our lab that is about 60% larger than the average residential window size in the US, and we'll scale up to patio door size in our pilot plant. With the recent closing of a $3 million venture capital round and a $1 million ARPA-E grant, we've begun developing the prototype production technology that will be demonstrated in our pilot plant and optimized by production lines with our manufacturing partners. More than a third of all capital raised to date have come from government funding, where we recently delivered on a Army ERDC Works project and are in contract discussions with the Department of War for a demonstration project, which moves VGlass from TRL-6 to TRL-7. We've accomplished all this with a very small technical team, all highly innovative problem solvers, named inventors on more than 200 patents. On the right, you see numerous organizations collaborating with us, including the DOE, which provides funding and technical support. As I mentioned, we recently closed a $3 million VC round and a $1 million grant from ARPA-E, which brings our total capital raised to $12.5 million, of which $5.2 million have come from 21 separate non-dilutive grants. We're in contract discussions for a $1.8 million Department of War demonstration project, and we'll be applying for other grants in the future. Future funding of about $10 million will be raised for global rollout, where we expect 50% or more to come from non-dilutive sources. That said, V-Glass is likely to be acquired well before all that capital is raised. So today's ask, I'd like to start early discussions with potential investors on our Series A round, which would be used to fund our pilot plant in 2028. Our investment thesis begins with V-Glass's disruptive VIG design and IP portfolio, which creates significant barriers to entry. We've got 29 patents that have been awarded, 11 are pending, and significantly more in the pipeline. An accelerated focus on global sustainability and resilience brings significant tailwind for our affordable energy efficiency technology. Those tailwinds show up in the form of non-dilutive public grants and direct funding for demonstration projects. Our 10-year relationship with the DOE also provides access to national labs and scientists, which keep us at the forefront of building technology. I'll conclude with a few final comments. Energy drives human flourishing and the global economy. Significant amounts of energy are wasted through the windows of buildings. Ultra-high efficiency, affordable V-Glass can have a significant impact both economically and environmentally. Be happy to take questions now.
Thank you, Mike. Cooper, go ahead.
Mike, thanks for the presentation. When I think of incumbent big technologies, I think of things that are very difficult to manufacture and require high precision manufacturing. Can you talk about how you perceive or how you expect the manufacturing for this technology to compare to that of incumbent big technologies?
So the big technologies you're talking about, I guess we refer to as first generation, and they're characterized by a rigid edge seal that's created from essentially what's called solder glass, which is molten glass that has to go through a high temperature oven process. Our edge seal is created by ultrasonically welding glass, metal to glass at room temperature. And we've been demonstrating that in our lab since 2022. And our product has been rigorously tested internally as well as at third parties, including the DOE's National Lab of the Rockies, I guess it's called now, instead of the National Renewable Energy Lab. So we've had deep relationships with two large insulating glass manufacturers that we hope will be our first licensing partners. So they've seen what we're doing in the lab, seen our processes, and we've also had vendors that provide equipment to this industry who have been in our lab and seen our processes. They all agree that the processes are fairly simple and to some extent mirror current manufacturing for dual pane windows. And so we still have a lot of work to do. And in fact, the $3 million VC round and $1 million ARPA-E grant is getting us kicked off on the development of the automation and manufacturing technology that you asked about.
Okay. And just to be clear, are there any micro pillars in between the panes of glass?
There are pillars. Well, we call them whiskers because they're shaped differently than the pillars that are used by first generation vacuum glass. And it's one of our design advantages.
Gotcha. Okay. Thank you.
Cool. Mike, you want to talk a little bit about some of the, if you're allowed to, the traction you have with the federal government?
So as I mentioned in the presentation, we've raised 5.2 million of the 12.5 million that we've raised so far from DOE, NSF, and State of Wisconsin grants. Through our relationship with Eagle Point Funding, we've about a year ago initiated an effort to secure relationships with the Department of War. We've already secured a very small contract with an Army research and development lab out in New England, and we're in contract discussions about a large demonstration project whereby we would be replacing single pane windows in Department of War buildings. And, as I mentioned earlier, the Department of War is one of the largest consumers of energy in the world and has about 300,000 buildings, in their portfolio.
Yeah, absolutely.
Was that a pitch for you, Asher? Is that right? Happy to do it.
Yeah, I didn't ask for it, but you did it. No, I was just excited about the most recent contract.
Yeah.
That's really exciting for me. I mean, as an outsider, it's fun. It's good stuff.
Yeah. We've gained a lot of traction recently, and it's very encouraging. And we've had a deep relationship with the Department of Energy for a long period of time. And one of the reasons we engaged with Eagle Point Funding was that, even more than a year ago, we felt that Department of Energy funding was waning, while Department of War funding would likely, hold steady or improve. And certainly under the Trump administration, that's coming to fruition.
Yeah, that makes sense. Well, thank you so much, Mike. Thank you for the presentation. Feel free. I know that your email's already on the slide, but feel free to leave it for folks who want to get in touch with you.
Yep. Thank you.
Awesome. Oh, wow. That was all queued up. Awesome. Thank you. All right. With that, we end the first session. We're a little late / a little, early. So with that, what we'll do is we'll go around and quickly have everyone introduce themselves one more time. I know that there's a few new faces and a few faces who have been on the whole time but have not yet introduced themselves. So Brent, you want to go first and quickly just say hello and who you're representing?
Yeah, you bet. Can you hear me okay?
Yep, loud and clear.
All right, excellent. Yeah, I'm Brent from Greater Ventures, and we invest in early stage companies across technology areas, deep tech as well as other areas, and companies that have innovations that improve well-being for people and communities. And climate tech and energy has been a significant focus for us for quite a while. And we also run a private syndicate of industry leaders and angels, and mostly folks that are operators or active in the areas we invest in. But oftentimes when we invest, we also make our investments available for people in that network to invest alongside us, and so bring a community of folks to our investments. So for anyone who's ever been looking for ways to invest in deep tech startups, can always also feel free to reach out. So thanks for having me, and you guys are always a platform for people working on great things.
Yeah, awesome. Happy to hear that. And yeah, thank you for joining. All right. Next up, we have Thomas Blum.
Yes, hello. I'm in New York City. I'm an active clean tech angel for the last 20 years. I'm a partner at Clean Energy Venture Group, which is the angel side of Clean Energy Ventures. And I enjoy meeting companies from all around the world and funding some of that. Thank you.
Sure, absolutely. It's a pleasure to have you. Utkarsh, you want to say hello again?
Yes, Asher. Utkarsh, Technology Innovation Manager here at Vertiv. We do data center infrastructure management. So if you see the recent developments in the data center and the power required for that, so we are interested in different technologies which supports this advanced requirements from the data center industry.
Nice. It's a pleasure to have you. Samira, you're up.
Hi, everyone.
Hi.
Yes, sorry. Hi, everyone. Thanks for having me, Asher. Yeah, my name is Samira. I'm running Raw Labs Ventures, and that's an early stage venture capital with a hands-on support to the founders, pre-funding and after fund. So we focus on infrastructure system level thinking of change in an entire tech, and pretty much deep tech, frontier tech. So the focus of the fund is mainly on seed and Series A.
Nice. It's a pleasure to have you.
Thank you.
Next up, we have Marissa McGinnis. I think Marissa is, she might be away from keyboard. All right, Han, you want to quickly reintroduce yourself?
Sure. My name is Han Ko, company name Useco Group. We are a VC company, and we have a footprint on different continents. Our interest is from clean tech to energy to AI, all the way to deep tech space. So we have a pretty wide range of interest, and our check size is usually from $500,000 to $5 million. Also, that was right range. And for example, we just enter a investment agreement with a company in Spain and then also in South Korea. So looking forward to working with you. Thank you.
Absolutely. Pleasure to have you. Next up, Paul Garcia.
Hello again. Paul Garcia, contract support for the Air Force Office of Energy Assurance. We work on power and water for fixed installations 200 around the globe, and that's usually utility connected power and infrastructure. Pleasure to be here and continue listening.
Absolutely. Pleasure to have you. Avery.
Hi, Avery Liu. In the Bay Area, Silicon Valley, represent two organizations. One is an angel investment group called Venture Capital Roundtable. We are pretty much agnostic from a vertical standpoint, although energy has been focused for us, and we tend to like to look at energy deals. And then on the other side of the fence, for the VC firm, Venturing Capital Group, we look at foundational IP that can be broadly used and licensed. So AI, robotics, quantum computing, life science, energy, and new materials. So energy would be a focus as well.
Sure. Pleasure to have you. Winnie, you want to quickly say hello?
Sure. I'm Winnie with Ajinomoto Group Ventures, a Japanese company with an advanced material business. So our focus is really on deep tech that has a material angle. We have made a small number of battery investments, but we're still fairly new to this space. So thanks.
Yeah, it's a pleasure to have you. Peter? Liz?
Peter Ruiz, Kansas Department of Commerce, based in Los Angeles. Just travel back and forth, looking at anything that we could involve ourselves with either incentives or Office of Innovation, which might have access to some funds. And additionally, we have a lot of companies that have asked to introduce them to any kind of disruptive technologies. So anything on the transmission side, nuclear, oil and gas, anything energy, wind energy. So I'll leave it at that.
It's a pleasure to have you. All right. Mark Morgan.
Hello, Mark Morgan here. I work for the Air Force Civil Engineer Center, primarily on the call because we take sales pitches from industry and with interest of partnering on the AFWERX CyberSitter program. Thanks.
It's a pleasure to have you. All right. Thank you, everyone. And thank you for I didn't mention it, but thank you for the panelists from session one. And thank you for those who are staying for session two. And thanks to the companies who presented in session one. With that, we'll get going on session two. First up, we have Enosis. I believe that's Steve, or I think Steve is presenting.
Yeah. Hey, Asher.
Howdy.
How are you?
Good.
You were right. It is me. My name is Steve Cox. I am the CMO for Enosis. Can you guys see my screen?
Yep.
Awesome. So today we'd like to talk about adaptive decision analysis and performance training, or ADAPT. Really quickly about Enosis, we were founded back in 2000 by Jen Hu. We are a woman-owned small business. We have a very large manufacturing facility in Salt Lake City, Utah, with more than 30 engineers. We also have close to 40 patents, and we have a number of extensive in-house capabilities. Those include solid-state vacuum devices. This is a new technology that is radiation hardened, can withstand extreme temperatures. If someone would like to talk to me about that, that's another conversation. But we have put this sensor technology into nuclear facilities because of its very high radiation capability, more than 100 megarads, withstanding for 100,000 hours lifetime. So if you would like to talk about that, please let me know. We also do additive manufacturing and 3D printing. We offer power supplies and electronics, We are experts in high frequency communication and radar, as well as extreme environmental electronics and systems. And then another thing, given this audience, that we thought you may be interested in following up on is a technology that we have called THREE. It's thermionic heat waste recovery to electrical energy. So this is essentially what would otherwise be waste heat recaptured as electrical energy. It's called THREE, and if you'd like to talk to me about it, please let Asher know. But today we want to talk about ADAPT. So right now in grid operations, we're experiencing a number of different problems. We have an aging workforce. So a lot of the people who are running the grid right now are retiring out, and they are taking that knowledge with them. The grid is getting increasingly complex. We have lots of new types of energy that's plugging into it, and that can be problematic without the right training. And then there's a lack of interest overall in this new generation entering the workforce. These are very high-paying jobs that don't always necessarily require a college degree, but that interest just is, we're not seeing it. And also, there's a lack of focus, let's be honest, amongst individuals coming into the workforce right now. I blame TikTok and cell phones. Maybe some people are on cell phones right now. It's problematic. So we need a new approach to training. And also data centers. So data centers, as you all know very well, they are popping up all over the country. They take an enormous amount of energy. There are some AI-focused data centers that take as much energy as a city, a small city. A lot of these power sources, I believe the federal government now is allowing these to generate their own power, but these people still need to be trained. And also the operators that they are drawing from are operators that would otherwise work in the national grid in the utility industry. So with that, we will introduce to you experiential learning. This is not necessarily a new concept, but it's a very attractive concept to the current workforce based on the things that I just said. It's very practical, it's interactive, so it captures their attention. It's based on familiarization training. So we use a simulation. So when they are doing the training, they're actually seeing what they'll see on the job. And it also helps us evaluate potential success of given candidates. To continue, this really helps trainees understand what they need to do in an emergency situation by developing mental models. And it allows them to adapt to situations that they may not have seen before in all the training that they had. It's been proven effective time and again in multiple studies. So ADAPT itself uses situated cognition. As I mentioned, it is embedded within training, within simulations itself. We are mostly focused on the grid side at the moment, but we are developing the power generation side as well as we speak. We're probably within a month of launching that. It uses adaptive and interactive coaching, meaning every single time that a trainee goes through ADAPT, everything that they do within the simulation is recorded, and that coach can then go look and see where the individual trainee needs more support or less support. It focuses their attention. I know I'm going on and on about this, but that's critical, especially for this type of job where if someone makes a mistake, it can have absolutely catastrophic consequences. And again, also, we want to, what's the old saw? Hire slow, fire fast. When we get people in these seats, we want to be able to see that they can do the job as quickly as possible. It can take up to 4 years from the time that a utility hires a candidate to when they're actually able to do their job effectively. I'll say that again, 4 years. We aim to cut that down as much as possible. The results have been overwhelmingly positive. We've done studies with SMUD, Sacramento Municipal Utility Department. We over and over get 10, and this is an evaluation from the trainees themselves. I won't read all of these, but I just one. Like that the simulation was realistic, interactive, and parameters changed in real time. So we are able to engage the student. They're not just looking at a PowerPoint and an instructor and trying hopefully to learn this information. They're taking what they've learned and they're applying it. So really, the training needs a cultural shift. We need to provide a safe and reliable environment for people to be able to learn in. It needs to be adaptive, and This does satisfy NERC's requirements, so that's a beautiful thing. And then, it applies to other industries as well. We're looking at aviation and commercial pilot simulations. You probably know that's huge. So very quickly, Asher, I don't know how much time I burned through, but I would love to show just a couple of screens really quickly. This is the simulation itself. This is what the trainee sees. So they have a number of alarms going off. This is a use case that was developed by SMUD. They need to resolve these. They go through the geographical maps, all the different things that they would see within the actual environment of their real job. Here, they're speaking to a shift supervisor. This is AI driven. It's Mistral 3.8 trained on NERC's guidelines. So this isn't canned responses. We don't have them pick from a list what they would say. They actually say whatever they want, and the AI responds accordingly. They go through, if they want to change power and they do something that would be catastrophic in the real world, we interrupt them and let them know, they're about to shut off power to a city, something along those lines. And then they go through, and once they're done, we have an after action review. So as you can see at the top, every action that they took is recorded. We ask them questions about what they did and why. They answer us. We give them what an expert would have done, and then we have backup documentation, and we let them evaluate themselves. On the instructor side, they can see what every single trainee did, when they did it, and the number of points that was deducted for that violation. And then the trainers can also, instead of having to go through us or a third party, they can create their own courses using our CMS. In those courses, they can add imagery, they can add questions, they build the use case and the scenario. And it makes it much easier and much more cost effective than having to go to a third party company every single time. So then just our areas of interest are asked. We are looking for pilot partners for CMS course creation. We'd like SMEs to evaluate the AI generation. So the responses that we give, we'd like somebody to stress test that with us. And then any organizations that would like to run side-by-side comparisons, we'd love to see, in a pilot study, how well Adapt is compressing the amount of time that it takes for them to get their trainees up and ready to do the job. And then just again, another pitch for 3. If you'd like to talk to me about this, please just let Asher know. We'd love to have a separate meeting on that. And then with that, this is my contact information. I really hope to hear from you. And if you have any questions, I'm happy to answer.
Yeah, Tom, you want to go first?
Yes. So just to clarify, is this a business that has already been spun out of Inosys, or are you in the process of spinning it out, or are you already an investor in a third-party company?
So this is wholly owned by Inosys. We have not spun this off yet. It's in early phases, in sort of early stages. It came about from a grant from the Department of Energy. It was extremely successful, and now we want to grow it. We want to make it.
Okay. So there's a lot of information that you could have given to a crowd like this that we would normally get on sort of who's running the business, what their background, what the customer attraction is, and a few others. This is a valid business. The GSE did this as a small public company for years for nuclear plants. So running training programs is good. It's sort of a niche business, but very legitimate. And we're probably going to need a lot of these. But I didn't get any sense of what the competition is, why, how you get paid, and a lot of the economics of the business. Thanks.
Sure. Yeah. And Thomas, we don't normally pitch to investors. And so I do understand, and I do have a deck that would have all the information that you need. But if you want to have a separate call and go over those kind of details, I would be more than happy to make myself available whenever you're available.
Okay. Thank you.
Awesome. Thank you.
Sure. Other questions? And I'll ask a quick one. Do you want to give us a little bit more in terms of other use cases or other verticals that you think that you could tap into in terms of Adapt? Because I know that we spoke a little bit about some certain ones, so I'm happy to Happy to hear more.
I would say that what we see to be the most applicable right now would be aviation. Right now in a sim with commercial aviation, you will have a number of different people. You'll have the pilot, you'll have the instructor, you will have people from the FAA, people from the commercial airline company like Southwest. All these different people in the sim watching the pilot trainee go through the motions, they still miss really critical things like bank angle. Adapt doesn't miss that stuff. So we see that as being the most lucrative next industry for us.
Well, thank you so much for the presentation. Make sure to leave your contact information in the chat so that whoever would like to contact you would be able to.
One quick
Awesome.
question. Sorry,
Yeah.
Asher. So is that,
Go for it.
Steve, are you guys only focused on US partnerships, or what about Europe?
At the moment, we really have been US focused, but we are completely open to European partnerships.
Because I'm connected to the aviation there very well. So anyway, if there is any interest, we can always set up a call and see how it can help.
Wonderful. Thanks, Samira.
Sure.
Perfect. Thank you so much, Steve. So feel free to leave your information and yeah.
Will do.
All
Thank
right.
you.
Yep, absolutely. Next up, we have West Coast Simulation. Feel free to start sharing whenever you're ready.
Okay, thank you very much. All right, can you see the screen okay?
Yep.
Okay, great. Hi, my name is Carl Meinhardt. I'm a professor at the University of California at Santa Barbara, mechanical engineering, backgrounds in thermodynamics, heat transfer. And so I have a spin-up company called West Coast Simulation. And what we're commercializing is a vapor phase compression for energy reuse. So let's change slides here. So as we're all aware, data centers in the US is going to consume about 9% of the total US electricity by 2030. And so most of that energy that goes into a data center is wasted to the environment. If you're using air conditioning to cool the data center, another 30% of the electricity that goes into computers goes into air conditioning, and it's all dumped to the environment and all wasted. The problem is that data centers, the heat that comes off of a data center or any high performance computer is typically relatively low temperature, 40 to 50 degrees Celsius, somewhere in that range. And if you want to reuse that energy, it needs to be bumped up to a higher temperature. So it has basically a higher thermodynamic potential to do useful processes. And so what we're proposing is we have a novel vapor compression technology that can actually bump that temperature up and heat water. And the idea is that we want to heat water to 80, 90 degrees Celsius, but do it in a very efficient manner that doesn't take a lot of additional electricity or energy. And then the users of this will be like modular data centers, industries, universities, government complexes that can then use that energy for things like district heating, for example. The current state of the art is people have been doing this, but in a more inefficient manner. So in Europe, for example, there's a lot of district heating that happens, and a lot of stuff that's generated using regulations. The idea is that you'd have a data center generates the low-grade thermal heat that then goes into a separate cycle that has a heat pump, and then the heat pumps can pump up that temperature to say 80, 90 degrees Celsius, and then heat water, and then that water can then be distributed through district heating to apartments and various buildings. The problem with this is it's all about efficiency. So the current state of the art, the coefficient of performance is about 3 to 4. What that means, if you have a COP of 4, that means for every 4 units of useful heat that you get out of it, you have to add in an additional unit of energy in order to bump up the temperature. So that's expensive. And what we want to do is get by with much more efficient processes where we can bump this heat up with maybe additional 10% energy, maybe 5% energy. So how do we get the temperature up without a lot of additional cost? And that's where this technology comes in. So the idea is that you would cool the computers, and these, if you look at NVIDIA now, their high performance computers are all cooled using single phase liquids. And what we want to do is use two-phase liquids. And this is an example of a cold plate on top of a GPU. And that cold plate will actually boil the fluid, do a two-phase, do a phase change. And then the latent heat due to the phase change will absorb a tremendous amount of energy. Now we take that vapor that comes off of the cold plates and then separate it out to make sure it's a very high quality. So the vapor portion of this will then go into a compressor, and these are off-the-shelf scroll compressors that when you compress at constant entropy. So that drives up both the pressure and the temperature of the refrigerant. And when we do that, if we go directly from the liquid that's being phase changed on the GPU, we vapor compress it to a very high temperature, maybe 100 Celsius. Then we can go through a counterflow heat exchanger and take water that's maybe at 60 degrees Celsius initially and put out water at 80 degrees Celsius, all while keeping the temperature of the computer below, say, 80 degrees Celsius. So we can keep the computer at its low operating temperature where it wants to be, but yet we can effectively generate very hot water at the same time. So we're actually cooling the system with hot water. And so that makes it unique in this way. Then once this high pressure, high temperature vapor is condensed to a counterflow heat exchanger, it then goes through a flow restrictor or pressure regulator that can drop the pressure back. It's liquid at this point. It drops the pressure of the liquid back down, and then it's returned to the GPU. So that's the thermodynamic cycle. So at the end of the day, what the customer cares about is that they get hot water. What the data center operator cares about is that they get information. And so this allows you to not only does it conserve energy and we don't waste the energy, but it also is economically beneficial because you get paid twice. If you're an AI inference data center, you get paid for your information with the AI inference, but then you also can get paid for the hot water that you deliver. And hot water is useful for a lot of industries, like food processing plants, DI or desalination plants, breweries, things like that. So there's a lot of uses for industrial uses for hot water, in addition to district heating. But you can also imagine going to, say, university campuses, large industrial campuses where they have centralized furnaces that then heat the whole complex. We can do that then with a data center at the same time. So it really stems into this whole decarbonization movement. You can also do things like direct air capture. So if you're interested in pulling moisture out of the air to collect water in remote locations or in arid locations, you can do that. You can also do direct capture of CO2. And so capturing CO2 is another way to decarbonize the atmosphere. And there's an article that came out from Microsoft a few months ago that Microsoft plans to repurpose 70 to 85% of its waste heat to remove CO2 from the atmosphere. So there is an industrial push for this type of thing. In addition, people in the energy sector want to do efficient oil recovery. And there's some pilot projects where they capture CO2 from the environment and then use that CO2 to enhance the recovery of oil. So they claim that the net contribution is that it's actually carbon reduction because they're effectively pulling more carbon out of the atmosphere than they are generating carbon by extraction of oil at the same time. So there's a lot of synergies that can win with this type of process. And the key innovation here is that we can do it efficiently with minimal energy. We have a couple of issued patents already. 2 more are allowed that should be issued in the next couple months. And we have a couple more patents pending. So we're getting good patent
We should
coverage.
start wrapping it up.
Okay. Yeah, last slide. Okay. So in summary, electricity is going to be a big issue, and by 2020, it already is, but it's going to be even more. We can generate hot water with very high efficiency. Quite a few different applications for the hot water. We're looking for seed Series A investment, and also strategic partners that are interested in data center cooling. And there's my contact info. So that's it. So any questions?
Yeah, it looks like Tom has a question.
Yeah, just starting out, where are you in terms of demonstrating the overall performance of this system for a data center in an actual data center?
Yeah, we're pretty early. We've been focused on filing our IP, and I'm a thermodynamics professor. So I've done a lot of work with different thermodynamic cycles, looking at the theory and how we can get effectively very high performance. We haven't actually built hardware to date. We're planning on doing that in the next 3 or 4 months. So we're looking at seed funding and Series A investment. But so we haven't built anything yet, but we're a few months away from demonstrating it.
And then, so you're a group of talented engineers, right? And then this is one of your inventions. This is when you control it. Have you put all the IP into the company yet, or what's your plan on the relationship between Inisys and this company?
Well, we're not involved with Inisys. That was a previous topic.
Sorry, confusing with West Coast Simulations, your modeling company that you have. You're spinning it out. Can you tell us what the relationship between the two companies will be?
Yeah. So for sure. So currently, so this project started with a Bitcoin miner, Mara Digital Holdings, and we're currently finalizing the details as to spin that out into West Coast Simulation. So the plan is the IP isn't in the company yet, but we're planning on getting in the company in the coming weeks. But the details the I's haven't been dotted yet, but we're in the process of moving the IP out.
Okay. Well, we look at data center cooling all the time. You've combined several businesses in here. The cold plate, two-phase expansion is different than the water cooling and other mineral oils that people use, or just liquid nitrogen. So it's a more complex process. So hopefully we'll see an opportunity when you guys are ready to sort of deal with outside investors. I'd say it's too early for for many investment groups. It needs to be nurtured for a bit.
Yeah, I would agree with that. And so we're planning to bootstrap it to show to a demonstration platform. And then when we have that demonstration platform in a couple of months, then that's when we're seeking the seed and the Series A money. But yeah, I agree with that. I think we want to do we need to demonstrate it first. Yeah. And we're in the process of that. We're working with strategic people. We have the equipment arriving in a couple of weeks. So this is evolving. So I think we will get there pretty quickly.
We have time for one more question. All right.
Sure. Carl, is there anyone else who's working with you on this? That's a part of your team that will likely be a part of the company as you take it forward?
Yes. Yeah. So I have another colleague who focuses on controls. Will be in it. So there's 2 of us right now. So we are very early stage. There's 2 people in West Coast Sim that specifically focus on this. Yeah.
Perfect. Thank you so much, Carl. Feel free to leave your contact information.
Okay.
Next up, we have Pure Blue Tech, and Ryan will be presenting. Ryan, feel free to get going whenever you're ready.
All right. Can you hear me okay?
Loud and clear.
All right. I'm Ryan Vogel, CEO, founder of Pure Blue Tech. Very happy to be with you all. Our mission at Pure Blue Tech is to transform the economics and sustainability of treating and reusing water, as well as desalting water, across industrial and municipal applications. The way that we achieve this is through an intelligent, self-cleaning, reverse osmosis membrane element. That's a mouthful. What that means is it's a smart self-cleaning filter for water and wastewater across industrial and municipal applications. So as many of you know, membrane separations, including reverse osmosis, is used across literally every industry. I've not found an industry or application, even the cloud, data, everything runs on water. Food, manufacturing, semiconductors, and of course, traditional water and wastewater applications. The global water and wastewater market is north of $750 billion. Within that, about 36 to 40 billion is the reverse osmosis membrane systems. We do not make the systems. That includes the pump and the valves and the stainless steel. We make the membrane element, the filter that actually does the hard work of separating the water from what's in the water. So RO membrane elements, about $5 billion global market, steadily growing very consistently. Some applications as high as 15% CAGR. We are focused on the high fouling and high scaling applications initially. The problem with membrane filters is that they get fouled and scaled, and that there is no way to actually monitor their health state and performance. They don't report anything back to the operator directly. The operators are really only measuring aggregate water quality and system performance information upstream and downstream of the system, not actually within the membrane elements. And due to fouling, excess energy is consumed. The system is shut down for chemical cleanings. The membrane elements have to be replaced. Ultimately, the cost of treating and reusing water would be much lower if you can solve fouling and scaling, and then we can move towards automation if you have intelligent monitoring. So we make the reverse osmosis membrane element integrated with ultrasound and sensing monitoring technologies, and up and coming also nano-imprinted membrane elements. So we do not change the membrane itself. We buy best-in-class membrane from the leading manufacturers that the customers already use and already trust. And then we roll and assemble, produce the integrated technology membrane elements. So they're plug and play, drop into the system. And then with that hardware sales, also a SaaS sale opportunity. Standard membrane on the left, our membrane on the right. You can see that it stays clean. This is more data to show we've resisted scaling here by 90%. Blue line is with ultrasound, orange line is without. Productivity falls due to scaling, and when you can prevent scaling, you can keep your system online and productive. This is a different feed water here, with a different type of foulant. And you can see also that we're reducing this by 75%. So the technology has been validated in the field by the Bureau of Reclamation, and we have a series of purchase orders and additional installs that we're planning over the next 3 to 6 months to really build out that initial case study portfolio of about 10, and that's where we'll really scale the business next year. Here's a screenshot, screen grab of our data that we're receiving from our units: pressure, conductivity, temperature, flow, everything you want to know about the health state and performance. This is what a membrane element actually looks like. It just slides right into the system. There's really no change to the system or infrastructure required. There is an external power driver for the ultrasound unit itself, but that doesn't require a change to the existing system. So we resist fouling and scaling. We have intelligence. We have the opportunity for AI. We're building that machine learning model so that the system intelligently cleans itself without input from the user. The bottom line here is OpEx savings. 20% OpEx savings is the target. So more water, less energy, less chemicals, less downtime, less maintenance, less labor, less waste volume. We focus where we make the most money the fastest. That's in the industrial segment. Customers move faster there. Nonetheless, we have all of the largest municipal utilities in the United States, Western United States, interested. LA, San Diego, Orange County, Inland Empire Utility Agency, the consulting engineering firms, and others. So one thing that makes us unique, not only does our product clean itself, but it is offering a new set of data. We're talking 100 to 1,000 times more data than the facilities have today. You could say they're flying fairly blind currently. So that gives us an opportunity for SaaS. So we've secured and completed $3 million of government contracts and grants to date. That's been $3 million of $10 million that we've raised. And that $3 million is non-dilutive. We have a very large opportunities pipeline, more than 120 million in the pipeline, and we're looking to close 1.5 to 2 million of POs here over the next 9 months, so this year. And we're at about 750K of purchase orders currently. Our model is to sell direct to the end user initially, and we are working with consulting engineering firms and OEMs and channels to really scale the business so that we don't have to hold all of those end user relationships. But initially, we really value those end user relationships. The end game is to sell the business to a major membrane element manufacturer. My team and my board have built, run, or sold 4 out of the 5 major membrane companies that comprise the market. Toray, Hydronautics, LG, Nano H2O, and Osmonics, which is now Veolia. We just moved here 2.5 months ago, Bellingham, Washington, 48,000 square foot facility. That's where I am right now. You can see the water over there, very beautiful place. So we have all the power and water and wastewater and utilities, everything, space that we need. We have one full production line that is established, and we can, on that, at max capacity, once we hire more people, produce about $10 million of product per year. This facility can allow 4 to 5 parallel lines, so we can get up to about $75-80 million per year revenue business in this facility. This is our team. It is what gives me the most confidence next to our technologies. Randy Truby, he's got about 50 years of experience leading membrane companies, as I've mentioned. Dave Paulson as well. Jeff Frank, chief engineer, lots of experience across naval, ultrasonic, and marine applications. Marcos and Pauly Reyes on the lower left, they have run and led manufacturing of membrane elements for 4 out of those 5 major companies. All right, so right now, actually 2 investment rounds that I'm raising for. I'm looking for a lead investor for a $15 million Series A. Again, historically, we've raised $10 million. 3 million of that non-dilutive, 3 million dilutive. And as a lead up to that Series A, I have 2.6 million available on a convertible note, which is effectively a bridge that gets us over that $1 to $1.5 million PO mark. Half of that delivered and moving towards the reorder point. That's when a business really begins, is when you have reorders from existing customers. So that convertible note gets us to that and to the Series A. Series A will be cash flow positive with that funding. And got a good exit path. Happy to talk more about that. Again, my team's done this before. So in summary, we solved the number 1 and number 2 issues with membrane separations and filtration. That's fouling, scaling on one hand, and lack of data on the other. 2 issued patents, another 4 patent applications pending. 1 core integrated product that we don't have to drastically change to go after all of these applications. Team's very experienced. We've got the supply chain in place, manufacturing facility here, and very significant traction, lots of interest. Happy to open it up to questions at this point.
Sure. Yeah, the floor is open. Tom, you're unmuted. Do you want to go first?
Well, I don't have a question. Why don't we?
Okay, sorry. Marissa, go ahead. Sorry about that, Tom.
Hi. So does your process, does it clean it? Is it self-cleaning? Did I understand that correctly?
Yes, we do not eliminate fouling and scaling. So the chemical cleanings will still need to occur, but they will occur much less frequently. So we're seeing 50 to 90% reduction of fouling and scaling, which means 50 to 90% fewer chemical shutdowns for chemical cleanings.
Okay.
And there's an associated energy savings, because if you can keep the membrane clean, it can produce that water without increasing the feed pressure. So this is really a carbon and an energy story at the end of the day.
Thank you.
Thomas,
yes,
go ahead.
I'll go with the question. So you made a great presentation. Just how much more is this going to cost me than the filter I'm buying now? And do I really need a sensor on every one of those tubes? I mean, aren't there thousands and thousands of those? And how does a sensor in one location give enough information about the condition of the whole tube?
Yeah, so price premium is anywhere between 25 and 60%, depending on the application, the value of our product in that application, and the volume, of course. The volume being, I think, the biggest factor that we're seeing right now. But so far, customers have been, and even municipal agencies are comfortable with that range of a price premium, 25 to 60%. For the large facilities where they purchase $10 to $20 million of membrane elements, they don't start with that large of a purchase. So it's a land, expand, scale model. Do an initial pilot of 50 to 100 units, or in some cases, a few hundred units, which for us is a great purchase order. For them, it's a pilot, and then move to thousands of units and then to 10,000 or more units. So we'll see how, as we scale, how we can drop our COGS and then drop our price as well. And then that SaaS, this is a new revenue model for this industry. Nobody has ever offered SaaS with a membrane. So we're honestly figuring that out with our customers, Los Angeles and the Empire Utilities Agency, DSALCOT, Intel, and others. To your second question, do you want to know the health state and performance of every subcomponent in your system? Good question. So far, the answer is yes. Customers are saying, of course, I want the data. And we think we have some good ideas about why they want that data, and they have some good ideas. But the honest conversation recently is, we don't know every use of this data yet, but we want to be able to have the data. So when an individual element fails in the whole system, if you can detect that, that helps you so that you don't have to do probing studies, you don't have to take out multiple membrane elements, setting the pressure, the feed pressure, setting recovery, determining when to do chemical cleanings, and within our own ultrasound system, the intelligent feedback loop of, now it's fouled, we're going to increase amplitude of the ultrasound to do precision maintenance, preventive precision maintenance. We may discover that you don't need every sensor in every membrane element. And so we might just do one train or one bank. It depends on the application.
All right.
Good question.
You want to ask one last quick question, because we have to keep things moving. Sorry, Ryan.
Terms on the convert.
20 million pre-money cap, 20% discount to the Series A, 7% interest rate. Series A, with the milestones that we have planned, will be significantly higher.
You fit with a lot of groups.
What's that?
You fit with a lot of my groups, the terms that you're offering.
I'm happy to hear that. I'd love to talk more and set up a meeting.
All right, Samira, one quick question.
Yeah, I have a lot of questions, but I think I will just keep to 2 questions. Is it okay? So just give me a little bit just an idea on the nano imprints, like the ultrasounds between the lab results and the field performance. That's a technical question. And the second question is more about your revenue. This is 140 million on pipeline. Sounds very impressive, but what is the conversion rate and the stage of the breakdown? And then on that 3 million in government contracts, how much of that is non-diluted funding? That's it.
Great questions. All 3 million of the government contracts and grants were non-dilutive. And we have a good amount in the pipeline, actually, working with the Deep Tech Showcase partner that helps with some of the grant applications that are very, very good. Eagle Point funding. The nano imprint technology is behind the ultrasound technology in terms of its commercial readiness. It still needs maybe about 12 months of work, and then we'll be able to commercialize that next year. To get 3 technologies to finish at the exact same point in time is a difficult thing. So the ultrasonic elements commercially ready now, and then the sensor integrated, we're going to be releasing those Q4 of this year, and then the nano imprinted elements. We do have some positive and favorable data in the field on the nano imprinted elements, but there's some improvements we still believe that we need to make, and then bringing in that roll-to-roll embossing equipment, nano imprinting equipment in-house. That's a step as well, and getting our comfort with that at that 40-inch wide roll-to-roll embossing.
In your conversion rate, because you're forecasting 140 million.
Can we just, sorry, Samira, is it okay if we take this offline? Because I really want to get to the last presentation before the hour. Just because I know people need to log off.
Sure.
All right.
Yeah.
Sorry about that. All right. But you guys should definitely connect. And I apologize. All right.
That's okay.
Last up, we have Mindco. Please, everyone, if you could stay for an extra 2 minutes for the Q&A for them, that'd be great. I know that it's the hour and everyone turns into a pumpkin, but go ahead. Go ahead, Doug.
Rory. Go, Rory.
Yeah, if you could give me the ability to share real quick.
Sure. Yeah, you have the ability.
Thank you. Can you see it?
Yep. Go ahead.
All right. Hello, everyone. Thank you for hanging in there. My name is Rory Roberts with Minco Technologies, and here I'm presenting Fortress, which is a fuel flexible, resilient technology for reliable energy supply and security. And the reason we do this is we're kicking off an effort to target data centers and other deployable power applications. With this technology, the market pain we're looking at is there's currently inefficient power generation. There's a need for more firm dispatchable power and some fuel flexibility. And our technology with Fortress is a hybrid fuel cell turbine technology that has 55% or greater efficiency at even 30 kilowatt. If you get up to 250 kilowatt, it starts getting above 60% efficiency. We can operate on fuels such as natural gas, propane, and be ready for renewable fuels such as renewable natural gas, hydrogen, ammonia, diesel, jet fuels. It's ultra low emissions, dispatchable power, and it's scalable. What this means to the customer is 50% reduction in fuel cost and CO2 that strengthens the grid with having these smaller deployable units that can be deployed, have high efficiencies as other large scale technologies. It's a lower cost electricity, and it's future ready for renewable fuels. Technology, the reason we look at this solid oxide fuel cell gas turbine technology is kind of looking at a lot of the power generation technologies, from internal combustion engines to microturbines to combined cycles to just fuel cells. This has the highest potential efficiency across many scales, from 30 kilowatts to megawatts. And we have patents in place that have taken this technology and scaled it to be even plausible in transportation or aviation, which some of our projects are aviation right now to date. But we think a good commercial market right now is for the data centers and power generation on the ground. With the Fortress, we're looking at a 250 kilowatt fuel flexible power unit. 80% of that power could be DC current, a DC power, so which could be rarely used directly in a data center, valuable for the GPUs, 800 volt DC. We are currently leveraging solid oxide fuel cells, a tubular technology from Special Power Sources, and also commercially available turbines. And these are micro turbines that are commercially available now, and so that are available in market. While doing this, we currently have a lot of other efforts that are working on right now. We have an Air Force unmanned air vehicle propulsion system based on this technology effort right now. We have an Army mobile electric power system on logistics fuel. We also have a NASA project with ammonia-based propulsion for zero emissions. And then we had an RPE reach based on renewable liquid natural gas for a single aisle aircraft. To date, we've had about roughly 18 million in non-dilutive government and private investments since 2020 in developing and testing this hardware. And currently we're progressing and doing the full system demonstrations this year. We see this market opportunity for this technology as a drop-in expansion or upgrade as current technologies for data centers that are going in today, between now and 2030, are required overhaul or rebuild. This technology would be something that would have a step change and a transformative change in efficiency. cutting the fuel usage. We also believe there may be opportunities if you're using half the natural gas that may open up more different sites for data centers or other technologies where you're not straining the natural gas infrastructure as much as if natural gas supply starts to become an issue and bottleneck in certain locations. So we see these applications, data centers, community microgrids, industrial power, critical facilities, a whole list below here for industrial decarbonization. From levelized cost electricity, our current estimates for this technology, looking at the capital cost, profit, maintenance, some stack replacements over a 10-year period, and fuel usage, is a little bit over 8 cents per kilowatt hour, which is a very competitive behind the meter power, especially if you can provide DC, a big portion of DC power for that. That reduces some of your thermal loads and some of your losses on site and some of your equipment needed on site. So we see this technology not only for data centers. Currently, I mentioned we have the Air Force UAV propulsion system we're developing. We also have, it can be used for ground, rail, air, and maritime. There's all opportunities in maritime and using ammonia directly if you want zero emissions. We only have water emissions. So right now we've had this 18 million dilutive funding from government and private. We have approximately $44 million in pending efforts right now across both DoD, DOE, and NASA. And we're interested in domestic, European, and Asian interests here. And just to highlight just one of our projects with the Army, we call it the Army HEPS. It's the Hybrid Electric Powertrain and Power Propulsion System. This targets ground vehicles, ground support, and propulsion. And what we've targeted here was a 30 kilowatt generator. As you see, is like Cummins AMP system. It's basically a mobile power unit using logistics fuel to deliver electricity out in the field. And this provides a comparison of where our fuel usage or our efficiency compares to existing technologies out there. As you kind of can see, we can operate up in the upper 50, close to 60%. And this is at a 30 kilowatt scale, while these various size generators operate at much lower efficiency and really low efficiency at part load. We have a much higher efficiency at part load, which is typically where these operate. And that can substantially reduce the amount of logistics and fuel burn for the Department of War by more than 50%. It also can increase onboard power for certain applications, has reduced platform thermal signature, and silent operating capabilities are possible as well. And one of the major things here is we're currently hitting our technical milestones. One of the things we're testing a gas turbine and a fuel cell. Right now it's a 14 kilowatt system, testing this overall system. This is pictures of it currently being installed, our fuel cell. And then also we're looking at a 1 kilowatt ammonia demonstration. We've already demonstrated this at certain scales with the SOC of using ammonia directly, converting power with zero emission. We actually are also working on doing some desulfurization methodologies or technologies we have to be able to enable us to use logistics fuel, such as jet fuel, Jet A, and JP8. And so this is kind of gives some of the milestones, and with that, that's what we're looking for today is, expressions of interest, engagements, and expansion advisory board after we hit these milestones, looking at putting together a Series A raise to go after commercial projects and domestic partners. And this is my contact information. I guess I probably went through that pretty quick, so maybe that's good.
Yeah. Thank you, Rory. All right, opening up the floor for questions. This is the last presentation, so last chance to ask questions. If anyone wants to speak up who has not yet spoken up. Thomas, go ahead. You're muted.
Are you making your own stack for the fuel cell or just using an off-the-shelf fuel cell?
So Special Power Sources is got the commercially available fuel cell technology, the tubular, and we are working with them to make the stacks that will go into this configuration, the 250 kilowatt. Depending on the application, the stack assembly changes.
Yeah, and so you're combining sort of a fuel cell, but also sort of a small turbine generator. So it's a hybrid system. Today, what's the largest system that you've been able to demonstrate?
So with those combined, we have not demonstrated them combined. We've only done, special power sources has done 5 kilowatts, the gas turbines 12 kilowatts. But if you start incorporating that together in the next month, we'll be demonstrating a full integrated system.
Okay, you must have something. I'm so curious about this because you got these 44 million of interest, and is it just that people in data centers are so concerned over where they're going to get their power that they're willing? By the way, have they actually signed something with you or given you a deposit for a first of a kind, not yet built system?
Well, let me clarify. The current efforts we have right now are for DOW and DOD and NASA. So those are looking at air mobility and looking at UAV type platforms. And so this system also, it can be compact and light enough to be an aircraft. And so in those cases, you're talking about increasing the endurance and the endurance of an aircraft. And this is something to expand on our ARPA-E Department of Energy efforts to look at the larger scale data center size power platform.
And where are you located?
Right, Cookeville, Tennessee.
So easier for me to get to. I'm in New York than the last two guys. So it sounds like you're a shop of very smart, experienced engineers that have been developing a bunch of these systems, but haven't taken any. Or do you have systems that you've taken commercial and are running and selling commercial products? Or are you more looking to spin out or sell these ideas?
We're looking to commercialize this product. So right now we're taking essentially 2 commercial technologies and integrating them to have more of a synergetic system. And that's where the kind of risk reward comes into play, because now you're taking these, already available technologies, but we're putting together for a efficiency that's very, transformative in a sense, doubling the efficiency. So if you look at this, I see this the next engine of the 21st century, because you're not going to be able to get these type of efficiencies with the regular heat engines. It's just not going to happen. And so trying to, make a gas turbine or any of these technologies that we're deploying today, they're going to be 40%. If you want to get up into 60%, you're looking at a combined cycle that takes several years to build, and you're looking at hundreds of megawatts, gigawatts.
And have you looked at oxy-fuel?
Oxy-fuel, as in
burning the natural gas with oxygen and not air.
You could do that, but I mean, if there was a very strong, I would say, decarbonization need, then that would be something that could be done. You do have the opportunity here, if you want to do carbon capture, you can keep the fuel and the air streams separate. So where you can take some of the products out of the fuel cell where you only have CO2 and water, you condense the water and you put out a CO2 stream that's constant. So if that was something that was desired, that takes very little hit on the overall efficiency. So if you do oxy-fuel, you have to do separation of nitrogen and oxygen in the air. Now you're looking at those membranes, you're looking at products like Air Products had and others. That becomes a 10 to 15% hit efficiency.
Yeah, it's the opposite, actually. You don't have to do the separation because there's no nitrogen. But
where do you get the oxygen at?
You have to provide that. That's
okay. Well, that's the hit. That's the hit. The 10 to 15% is the oxygen generation. I was including that. I'm assuming that's not free.
Usually not. No.
Sorry.
Well, there's going to be a lot of interest. You couldn't have a better product. It's rare for new first of a kind engines to get, or turbine generators to get this type of attention. This is happening now. There's a lot of interest in this.
Yes, we're receiving lots of interest, and the applications. There's a lot of different applications, and that's where I may have come across a little confusing on one of the charts that go back to what we had. Both.
And your system is about the size of a Bloom system. Is that the larger 150?
They're typically. There's 60 kilowatt modules, and they can scale up in a modular fashion, if I remember right.
Yeah, you just keep adding more of them. Well, and the market seems to be okay with that. Bloom is, I tell my companies, whatever Bloom is doing, do the same thing, because they're worth $45 billion, and people pay attention. So
Yeah,
if you
no, I
have
appreciate that.
what you didn't, I would have liked to have seen more comparison to Bloom or Tecogen or Yembach or some of the others. Percentage efficiency performance, that doesn't mean much to financial people like me. I mean, bigger is better, but I don't understand what that really turns into in the economics of running a system over a year, for instance. And
so if you look at the levelized cost of electricity, that's what they're going to be concerned in. So what does it cost me to get that power in? You're looking at some places on the grid plus 20 cents plus, or even technologies you do behind the meter, you're looking at 14, 15 cents. So this could be a substantial drop in cost, in operating cost over the 10-year period.
But in other words, you're all starting with natural gas and producing electricity, maybe some other heat or some of the other variations use some of the other material that's made. But in the end, it's how good is your conversion of that natural gas or hydrogen or something else. Okay, thanks.
No, I appreciate it. Thank you for the questions.
All right. With that, if we're done, you guys should definitely connect offline. But now that we've wrapped that up, thank you for the presentation. Thank you for everyone who joined. Thank you for everyone who presented. We really appreciate the participation, and thank you for the people who stayed overtime. And come back for next month's the Industry 4.0 showcase. So looking forward to seeing everyone there. Have a good one.
Thanks.
Yep. Bye-bye.